Right. Today we will discuss about the Spark and Spark architecture, and after that we will write some basic code how Spark will work on the and based on the Python. Okay, topics. Basics of Spark. Spark architecture. Basic code on basic code for Spark initialization. PySpark. Because we are using Python to initialize the Spark. So it's a PySpark. Basic code for PySpark initialization in PyCharm. And these are the topics today we are discussing about. First, here why we are basically focusing on Spark. Basically, Spark is a big data tool. Spark is a big data tool. Nowadays, we are using a Spark. Any project, whatever the project we can take, big data projects, data engineering projects, mainly they are focusing on Spark in cloud. With this much robust tool, why we need to use this much as Spark? Because it is a robust tool. Uh, Before the Spark, mainly the data field, big data field, they are using MapReduce in Hadoop. Why they have replaced the MapReduce and why they have taken the Spark as a computation engine? Yeah, Spark is a computation engine. That first, mainly we can discuss about the definition, right? Spark is an open source. Open source fast computation engine. This is the basic definition for the Spark. This is the basic general definition. It is an open source. Spark is an open source fast computation engine, and we can use the Spark in many fields. We can use a Spark in many for batch computation, streaming. Streaming is nothing but real-time data. Mainly why we are using the Spark, because it's streaming also. When we go through the MapReduce and Hadoop not have a capacity to stream the data, real-time data. But Spark have the capacity to grab the real-time data with its computation engines and with its open source techniques. And we can do ML operations. ML nothing but machine learning operations. Machine learning operations. For these purposes, for this purpose, mainly we can use a Spark. And Here we need to discuss about some questions. Why we need to use Spark? Why Spark? But because it is a when we use a Spark instead of Hadoop, because of it is speed. Go through with Hadoop. We can use in Hadoop. We can use a MapReduce. MapReduce. These MapReduce will compute the data in disk. That's why MapReduce is slow compared to Spark. Spark, we can use in-memory computation. So Hadoop is compared to Spark, Hadoop is slower. Why? Because in-memory computation compared to disk and in-memory, we can get the data from disk. We can get the data from disk, but it is a slow process. But when we compare to the RAM is a faster, right? Uh, the RAM is not but in memory. When we take the in memory, when we extract the data from in memory, the transformations are faster and we can get the data, we can read the data, write the data faster than Hadoop MapReduce. This is that why we are mainly focusing on Spark. Here, main Spark is 100 times faster than MapReduce. And one more thing, Spark is 10 times faster than MapReduce when we when we data when we read data from with disk. Here MapReduce, when we take Hadoop is 100 times faster than MapReduce. Hundred times faster than MapReduce when data with in memory. When we read data in memory. This is a comparison. Even we do the, even we take the, we can read or write or we can do transformations with help of the disk also. It is 10 times faster than Hadoop MapReduce. For this purpose, mainly we are using the Spark. We can revise it. Why Spark? Spark is an open source, fastest computation engine. Why fastest is because it is 100 times faster than MapReduce. In memory, it is 10 times faster than MapReduce. In disk, we can compute, when we take the Hadoop MapReduce will compute in the disk, but Spark can compute in the in-memory. So that's what that purpose, Spark is faster than Hadoop. And Spark is an open source because, and why we are in which streams we are using Spark? Mainly for batch computation or batch computation. Stream is real-time data. When we get the data from different sources, real-time data. Real-time data is nothing but when we scroll any e-cart site, when that scrolling data, will be directly, that company directly take the data and store into that database, your data. When we scroll the product, it will store and it will give suggestions, this product is available. For that purpose, they can use a real-time streaming data with help of the big data. That is also a real-time project. And after this, Spark is faster compared to Hadoop. It is a distributed computation engine. Distributed is nothing but when we it have more worker nodes. In future, we will discuss about advanced analytics. Even we can do the analytical analytics is nothing but we can do the ML operations with help of the Spark by adding the more libraries to it. And real time. Real time is nothing but we can take the example like explain the streaming data. There is the real time data, powerful catchment. Fault tolerance is nothing but we'll explain on the fault tolerance. Why is fault tolerance? Before fault tolerance, we need to explain about the mutable and immutable. Compared to when we take up in Python, pandas is mutable. Why? Because when we take the data frame, we can rewrite the data inside that column or inside the row. That why we can make changes in the data frame, change the data in data frame. We can change the data in frame. This is called as a mutable. And compared to Spark, Spark is a immutable. Immutable. We cannot change or modify data in data frame. When we go through with future transformations, then we can understand why it is an immutable. Because the immutable property only we can reach the fault tolerance. And why fault tolerance? Because of it, in Spark we have a concept like RDD, resilient distributed data set. In future we will discuss about the resilient distributed data set and fault tolerance and why is this mutable and immutable. These concepts is enough for the basic understanding. Okay, this is the basic about the Spark. Today we discuss about the basics of Spark. Now we can go through with the Spark architecture. Why how we can use that Spark architecture. If we're going to the architecture, we can see some important questions like difference between Spark and Hadoop. We have explained about Spark and Hadoop. Why Spark, not Pandas? We explained about, right? Immutable and mutable concept. This is the main advantage. Why Spark and not Pandas? Not only that, Spark is a parallel computation engine. Spark is parallel computation engine or processing engine is also main point. There we can use Spark. We have explained, right? We can use a Spark in big data concept like batch processing and batch streaming. Sorry, batch processing and streaming data, and for ML operations also we can use a Spark. For this purpose, we can use Spark. Spark can store data. This is the main point. Spark can store data. Spark can store data? No. Why? Because it is a computation engine, not a storage device. Okay, it is not a storage device. It is just a computation engine. With help of the RAM and with help of the open source code, we can run the Spark in computation engine. But where we can store the data? Even when we do the real-time projects, we can store the data in the, if we go through with the cloud, we can store the data in the S3 in AWS, and we can store the data in Azure in blob storage or Gen 2. We have a different sources to store. We can extract, we can read the data in Gen 2 with in Azure Gen 2 and AWS S3. We can write also there. Mainly on real-time projects, we can take the data from that, even from Google GCP2. Okay, these are the basics. Next, we go to the architecture. Okay, this is the basic architecture of Spark. We have mainly Spark also equal basic. The architecture of Spark and Hadoop is similar. When we go through with Hadoop architecture also, the architecture is based on the master and slave architecture. Here we have same architecture, driver and workers. One driver have many workers. Okay, one driver have many workers. In these driver and worker is total inbuilt process is called as a cluster. Okay, in this cluster, mainly these Spark cluster, we have driver and workers. We have many workers, and we will go through with the each component of this. Okay, this is the basic architecture and basic components of Spark. Okay, here mainly first we can go through with the driver programmer. This is the driver programmer. Okay, this is the driver programmer. Can you see this? This is the driver programmer. Inside the driver programmer, we have a Spark context. Okay, we'll go through with it. Components of Spark. Mainly, we have three components. First one, driver programmer. Next, second one is cluster manager, and third one, worker node. Even the programmer, or we can call as a driver node. These three components mainly on Spark architecture. Okay, architecture. Here in driver programmer, in driver node, we have a Spark context. What the purpose we need to use a Spark context? Here you can see this is a Spark context, right? This is the Spark context. When we go through with the inbuilt coding, we can take as a PySpark or a PySpark in Python, and we can write a .py file. Okay, when we write the .py file, we need to submit that .py file at some location. Okay, these location in driver programmer only we can submit the spark.py file. In Spark context only, Spark context only, we can send that .py file. Whatever the application we have built, we can send that, or not only .py, whatever language we can use. Even the Spark will support for Scala, Java. Scala is equal to Scala and Python, and R language, or is mainly used for the statistical and mathematical purposes. Here we are using the Python, PySpark. Here, when we go through with the architecture, and in this Spark context, when the application is submit to Spark context, and Spark session is created. When we submit the Spark application to the Spark context, Spark session is created. Spark session is created is nothing but the Spark is ready to do the transformations and actions. Okay, we can discuss about what is transformations and what is actions in future. This is the driver node, driver programmer, driver node. Driver node is nothing but one type of computation engine computation box. And in this box, not only the Spark, in this Spark context is mainly used for application is submitted to the Spark context, and Spark session is created. To create the Spark session, we need to create the Spark session, we need to submit some application. The application is nothing but whatever the code you have written, right? That code is submitted to the Spark context. Then the session will be ready. Then the program will be ready to compute. Okay. Not only for this, a driver programmer will store the metadata also. Driver node will store the metadata of the worker nodes. Okay, worker nodes. Driver node will store the metadata of the worker nodes. This is our driver node, right? This will store the this one, right? This one. This will store the metadata of the worker nodes. This is the worker node. Whatever the data whatever the files we are getting, the file location metadata is stored in this driver program. Not only that, whatever the worker node data, which worker nodes, how many worker nodes we have, and how many executor, how many tasks we are doing, the total metadata of this worker node is stored in the driver programmer. That the main two purposes the driver program will do, it will to submit the Spark application, and it will create the Spark session. That is the first thing. And next one, it will create the, and it will first thing is to create the Spark session, and next thing is to store the metadata of the worker nodes and metadata of the worker nodes and metadata of the data, whatever we need to compute. Okay. The first driver program is complete. Second one is cluster manager. This is the cluster manager. Why we need to use cluster manager? Cluster manager is used to allocate the resources. The resources are nothing but the worker nodes. Resources are nothing but the worker nodes. Here we are seeing right worker nodes. These are the worker nodes. When we go through with the initializing the Spark cluster, we have only the driver programmer. Driver programmer will tell to the cluster manager to allocate the resources to do the computation or to do the data transformation. Driver programmer will tell to the cluster manager. Driver programmer will tell to the cluster manager allocate the resources. These cluster manager have only the job to allocate the resources, to check the resources, and if the resources is existed, it will allocate. These cluster manager will do only the purpose. Driver, it will check the resources, and if resources available, then it will allocate the resources. Resources are nothing but the worker nodes. So nothing but worker nodes. Okay. This is the main purpose why we need to use cluster manager. This cluster manager mainly we can use for many purpose, many projects we can use. Yarn is a cluster manager. This is the purpose of cluster manager. Again, we can repeat. Cluster manager is used to allocate the resources. Before allocating, driver programmer give instructions to the cluster manager. Cluster manager will take the instructions from the driver program and it will allocate the resources. Allocate nothing but it will go and check the worker nodes are existed or not. How many worker node it need, and if the all worker nodes are existent with the same configurations, yes, the configurations is okay, then the cluster manager tell to the driver program, yeah, worker nodes are existent, it is ready to do the computation. That way, that purpose only we can use a cluster manager. And the next one is worker node. In this worker node, worker node have the components like executors. In each worker node, we have the different executors. In on-premise systems, we can use different executors in each worker node. But when we go to the cloud, when we worked on the cloud, we have worked with the Azure cloud. In the Azure cloud Databricks, we can have each worker node have each executor in Azure cloud. But and in on-premise, I think we can give the more executors to do the computation. And in this executor, we have a cache and task. Tasks are nothing but simple words. Each task compute certain amount of data. What is cache? Cache is a powerful memory source, we can store small amount of data. This caching also helps a lot in Spark applications, okay? To compute the data, this cache also help for joining and for all whatever we can do the broadcast, and for broadcast we can use some other thing. The cache have separate thing, persist and cache. We can store the data in the cache, and we have the broadcast to optimize the Spark code, to optimize the Spark cluster. We can use all these techniques, okay? That purpose only we can have a small amount of memory, powerful memory. They have kept in the Spark, in the worker nodes cache. That purpose only we can use a cache. This is the worker node. Each worker node components. Each worker node have the same components. We can use 4 or 5 or 6 or 7 worker nodes with different configurations as per your cluster size. Okay, we'll go to the working principle. Okay, we go to the working principle, Spark architecture working principle. First, when you write the code, right? When you write the code, sorry, you can write the code. This code application, whatever you can write in Spark, or you can write in, sorry, not a, you can write in a Python, or you can write in Scala, you can write in R. That that application is taken by Spark context, and Spark context create the Spark session. Create the Spark session. First, we have discussed, right, when we are explaining about the driver program, what is the application, and what is the Spark session. When we have to create the application, thus when we submit the application, the Spark session is created. Spark session is nothing but it is the signal to, yeah, I'm ready to do work. This is the signal. Yeah, this is Spark. Spark session is created in the Spark context. And here we can use the whatever the data location we have, like we can give the path. That is this, and Spark session is created. Inside the Spark session, inside this driver program only, we can give the configurations like 4 GB RAM, 3 worker nodes. Worker nodes, okay? Configurations is nothing but we are giving configurations in this application. We are giving 4 GB RAM, 3 worker nodes. We are telling to Spark driver programmer that I need 4 GB RAM, 3 worker nodes. After driver programmer will tell to the cluster manager that I need 4 GB RAM and 3 worker nodes. Go and check these resources are available or not. This will happen in the architecture. We can tell to the Spark context that I need 4 GB RAM and 3 worker nodes. We can tell to Spark context. And what will Spark context will do? Spark context will tell to the cluster manager that I need 4 GB RAM, 3 worker nodes. Try to allocate resources. If resources are available, resources are nothing but worker nodes. If worker nodes are available, then go and create that resources. this Spark context will tell to the cluster manager. What cluster manager will do? Cluster manager will check the worker nodes. If the worker nodes are existed or not with this configuration, 3 GB RAM, 3 GB RAM, I have 3 worker nodes or not. Yeah, if 3 worker nodes are existed, the cluster manager give the signal to the Spark context that yeah, 3 worker nodes are existed with 4 GB RAM. I'm ready to, this cluster is ready to work. Worker nodes are existed. These are the worker nodes. Okay, and these are the worker nodes. In this worker node, whatever we have the cluster manager allocated resources, this cluster is created. After creating cluster, whatever the application we have written, right? Inside the application, we have written the transformations and actions. The total part, is the total application is sent to the Spark context, and the Spark context will send the application data, whatever the data is parallelly divided into these worker nodes. The data is parallelly divided and sent to the 3 worker nodes. Now, how it will divided, we'll discuss about it. When the data is sent to the each worker node parallelly, each worker node will work parallelly, and each worker node, whatever the data we have taken in this worker node also, that data is divided. That data is divided into different tasks. Okay, different tasks. Each task will work on the computation purpose. It will compute the data, and after computing, it will give the action. It will give action. Okay, this is the total architecture. And now we'll discuss about what is the nothing but after this we'll discuss about explaining on that. 1 minute. Yeah, we have completed the Spark architecture. And now we can go through with the basic code, how to initialize the code. Okay. For this purpose, I am using the PyCharm. This is my PyCharm. Here I have created one project called as YouTube. In this project, I have created a session.py. You can use any name .py file. Here I can pyj4 and PySpark.zip files. We can extract this file from whatever the big data or Hadoop big data and Spark folders we have, right? When we install the Spark, we need to extract these files from there. This zip file from there. Then we can start the code. Okay, from spark.sql import Spark session. Spark session. Okay. Here we need to initialize the Spark. Spark session dot builder. Master. Master is my, I'm using a local machine. Dot app name. And we can give the configurations. We can use the port number as 4056. This is the initialization of Spark. Then we can read the some CSV file. Spark dot read CSV. Here we need to give the path. I can give the path. I will go to folder. Here I have the, here I have some data. I have copied the path and I have pasted here. Okay, this is the path. After that, comma, we need to give the header. Header true. Why we are giving the header is true? Because if you not give header is true, it will not take the header as a, it will not take as a header, it will take as a row. The first column, the first row is taken as a same row. It will not take as a columns. So for that taking as a columns, we can giving the header as true. And we can use a separator. Here my separator is we can use the CSV files as a comma separated file. It is a column separated file. I also am using a column. Infer schema is nothing but we are not defining the data as a int or float or some other things. If we can use the infer schema, it will check the data and it will directly take that it is a string or it is an integer or it is a float. It would directly automatically read that it is a whatever the metadata it have. Yeah, this one. We can initialize a variable for this. HAS, we can use we can give the data dot show. This is the action. This is the transmission part to read the data, and this is the action. Show the data. Whatever the we can read the data, we need to show the data. We can run this. It is running. Yeah. Here we can see the data is read, right? Have a transport ID, vehicle number, delivery address, delivery status, and entry date. This is the columns we have. If we not take a header is true, or yeah, can take if we not take a separator, see that not taking the separator, how it will read. See, if we not take a separator, it will not understand what we it need to divide. So we can use it is necessary to know the separator. Yeah, this is the basic initialization of Spark. This is the basic code. Okay. In future, we can give this code into the below link. Okay. And we can revise that. What are the topics we have learned today? Basic topic, basics of Spark. In basics of Spark, we have defined that what is Spark and where we can use Spark. What is the difference between Spark and Hadoop? Uh, and after that, Spark architecture. And the Spark architecture, we have explained about components of Spark, driver, programmer, driver node, and cluster manager, and worker node. Inside the driver node, we have a Spark context. We have explained about the Spark context and why we need to use the cluster manager and why we have worker nodes and what is the architecture of that and how the data will flow in it. Explain about it. And after that, basic code for Spark initialization in PyCharm. These are the basics. In future videos, we go through with the in-depth concepts. Okay. Bye.